Welcome once again. We are going to the second part of our lecture 2, that is the dispersed systems in foods. Introduction to salts. By definition, we said salts are colloidal systems where a solid is dispersed in a liquid. And the types of salts we noted, we have the lyophilic salts, those are the solvent-loving salts, and then the lyophobic salts, which are the solvent-hating. How do we assess the lyophobic and the lyophilic salts? We can assess them by various distinctions according to the method of preparation, the particle charge, the solvation, the viscosity, and vice versa, and so many other categorizations. By preparation, lyophilic salts are simple in mixing. We use simple mixing, but lyophobic salts require special methods for mixing. Particle charge. Lyophilic salts have little or no charge, but lyophobic salts have a positive and a negative charge. By solvation, lyophilic salts are strongly hydrated, but lyophobic salts have no solvation at all. By viscosity, lyophilic salts are higher, they may form gels, and lyophobic salts are similar to solvents. By precipitation, lyophilic salts have high electrolytes, and lyophobic salts are shown by low electrolytes. Reversibility. Lyophilic salts are reversible and lyophobic salts are irreversible. We have what we call the Tyndall effect. The Tyndall effect is usually absent in lyophilic salts and it is present in lyophobic salts. Electric migration. Lyophilic salts show random or mixed, and then the lyophobic salts show opposite electrodes. They move towards the opposite electrodes. The preparation of salts. The lyophilic salts, we said, can be prepared by simple mixing methods, by directly mixing and warming the solid with the solvent. The example here is starch in water. The lyophobic salts, we can use dispersion methods, which include the colloidal mill, Bredick's arc method for metals, and then peptidization using electrolytes. The aggregation methods also can be applied. And in food chemistry, aggregation basically refers to the process where molecules, particularly the proteins, interact and cluster together, forming larger complexes. This phenomenon significantly influences the texture, the stability, and the sensory attributes of various food products. We have various aggregation methods, such as the double decomposition, reduction, oxidation, hydrolysis, and the solvent change. And we are going to understand each of these methods with formulas. In the double decomposition, we have a reaction between arsenic trioxide and hydrogen sulfide to form arsenic trisulfide sol and water. And this process involves the exchange of ions between two compounds, resulting in the formation of a precipitate that, when dispersed in water, forms a colloidal sol. In the reduction method, tannic acid acts as a reducing agent and it converts the silver ions from silver nitrate into metallic silver nanoparticles. And these nanoparticles usually remain dispersed in the solution and form a colloidal silver sol. And this method is commonly used in the green synthesis of silver nanoparticles due to its simplicity and eco-friendliness. Oxidation is another method of aggregation, and here this is a redox reaction whereby hydrogen sulfide is oxidized by sulfur dioxide, leading to the formation of elemental sulfur that precipitates as a colloidal sol. This reaction is significant in environmental chemistry, especially in the removal of hydrogen sulfide from industrial emissions. Another method is hydrolysis, and here ferric chloride undergoes hydrolysis in the presence of water, resulting in the formation of ferric hydroxide that forms a colloidal sol. This reaction is utilized in water purification processes where ferric hydroxide acts as a flocculant to remove impurities. And finally, the other method is the solvent change. Here, sulfur solution in ethanol is added to water. This process involves sulfur dissolved in ethanol being added to water, which leads to the formation of a sulfur sol. When a solution of sulfur in ethanol is introduced into the water, the change in the solvent's polarity causes the sulfur to precipitate out as fine particles that form a colloidal sol. And this method is an example of a solvent-induced precipitation, whereby a non-solvent is added to a solution to decrease the solubility of the solute, leading to aggregation. So this is the various aggregation methods explained. And how do we apply the various aggregation methods in food products? One, in dairy, controlled aggregation of casein protein is essential in cheese production, and this will lead to influencing the texture and the flavor of the cheese that is produced. In bakery, protein aggregation affects dough elasticity and bread structure. In meat alternatives, protein aggregation is manipulated to mimic the texture of meat in plant-based products. In beverages, it prevents unwanted protein aggregation, which is very crucial for clarity and stability in drinks, for example, beer and wine that you love so much. We also have the dispersion methods. We noted that the dispersion methods are basically three: the colloidal mill. This involves grinding solids into colloidal size. Then we have the Bredig arc method. Here, electric arc vaporizes metal into a sol, for example, gold and silver. Then we have what we call the peptization. This one, the precipitate turns into colloid using a peptizing agent. So what is the importance of dispersion in food products? Dispersion is also very crucial as aggregation. One, it helps in texture and mouthfeel. The distribution and the interaction of phases determines the creaminess of sauces, the fluffiness of baked goods, and also the smoothness of dairy products. Stability. The properly stabilized dispersed systems prevent separation, ensuring consistent quality and shelf life. Flavor delivery. It also aids in the formation of uniform distribution of flavors and aromas throughout the product. Nutrient delivery. Dispersed systems can encapsulate vitamins and minerals, protecting them from degradation and controlling their release during digestion. And this marks the end of our lecture about dispersed systems in foods. And I thank you so much for listening and being a very good learner. Thank you.